So in the last class, we were studying about mapping the value stream, and I have showed you the flow of or how the value stream was done, and how the flow, the information flow, product flow, and the time ladder has been given for each and every department that is shown, and value, sufficient value for each of the departments are given as 4, 2, 2, 2, etc. Okay, so this is how the value of a stream or a department is mapped. Next is create flow. So what is coming under create flow? Creating flow is about removing functional barriers to improve lead times. So we are removing functional barriers. So functional barriers in the terms of uh, in the terms of time taken for building a product, or wastage of time, or etc. Okay, these are all some of the functional barriers that occurs during a production process. So we have to create a flow in the sense there must not be any form of vacant times, or the production must continue in a flow, or it must go on in a flow, so as there so as not to interrupt the production process and reduce the number of products that is produced. So that for that purpose a flow has to be created, and you have to remove the functional barriers to improve the flow. And next point, this ensures that processes flow smoothly and can be undertaken with minimal delay or other waste. So removing the functional barriers ensures smooth flow. Okay, smooth flow with minimal delay. So that is what is the advantage of removing functional barriers. So we are reducing the delay that occurs, or the delay time that occurs between maybe interdepartmental process, or during a department process itself, if there is any wastage of time. So these delays are then minimized or eliminated by removing the functional barriers. Next point, interrupted and disharmonious production process incur cost, and creating flow means ensuring a constant stream for the production or service delivery. So two points are mentioned here. One is interrupted and disharmonious production. In the sense, if it is not a lean manufacturing process, then the processes consist of certain delays or interruptions or disharmonies. So there is no flow there. So if there is such a uh, such a production process, then the cost incurred during the production, or during the holding cost at the inventory, these all create an interrupted flow, and the cost incurred will be very high when compared with lean manufacturing, wherein we create a flow that ensures constant stream for production or service delivery. So if the customer even request for a particular product, we have to deliver the product, right? So the one of the advantages of lean manufacturing when compared with the just-in-time manufacturing is that we are we always have the product to be supplied to the supplier, or to the consumer at that right time, because of the amount of inventory of the product that is already present. So it will be present at a lower rate, but it will always satisfy the demand that is occurring for that particular product. Okay, if 100 products are required for a day, such 100 products will be available in the inventory during that day under lean manufacturing technique. So that is what is mentioned in the third point. Next comes the establish a pull system. So what is this pull system? So you can see a figure here, push and a pull system. So in a push system, what we do is the production is approximated. based on anticipation, inventories are high and there is waste. So that is the push process. So the production is approximated in the sense we are determining a demand. We are predicting that this product will be needed by a large number of consumers. We are predicting it, but maybe it will be less than that value. If it is less than that value, then the products that we are producing and kept in the inventory will be much greater. Okay, that is what is happening. So based on this anticipation, the inventories are always high. It is running at high. So when inventories are high, the problem is that the holding cost or the storage cost always increases. So such products um, must have to be sold first, but old products will not sell as much as newer products. Okay, so that is the problem of storing such products in inventory, and hence there is waste in the sense profit loss will be there. And if if the product is kept for sufficient time until its expiry date, then you have to normally dispose it, right? So in the sense medicines and food products, it is given an expiry date, and after that expiry date it is unsafe to even use the product, so you have to dispose it. So then there is waste. So such a process or such a system is always known as a push system. But in the case of a pull system, here is what it is done: makes what needed when need make or so make what's needed when needed. That means you are making products according to the demand itself. Okay, according to the demand only you are making it. So production is precise. Okay, production is precise. We are setting a value. If you need 1,000 products, and 1,000 products only will be released, not 1,500 or 2,000. We are not keeping an inventory that is high. So it is based on actual consumption only. Actual consumption in the sense according to the demand. So the demand that of the product or demand for the product is set as the actual consumption, and according to that only production is only commencing work when there is demand. See, that is the only thing that is coming under pull system. So for a lean manufacturing system, there is a pull system, and under pull system, it is said that the work only commences when there is demand. So according to the demand itself, the product is produced. So once inventory is present, under inventory, the products are being sold, and if there is no sufficient products to satisfy the demand, then we are commencing the work for the product. Okay, so always they will satisfy the demand. Next, this is the opposite of push system, which are used in manufacturing resource planning systems. So manufacturing resource planning will be studying in the next module. So that time I will tell you what is MRP systems. But know that it is just the opposite. In MRP system, it is the push type systems. But in the case of lean manufacturing, it is pull type system. Next, push systems determine inventories in advance with production set to meet the sales or production forecast. So push system always works in advance. In advance means you are predicting it. It's based on a prediction. So maybe that prediction will be right, but almost all the times it will be wrong. Majority of the time it will be wrong. So such a system is uh, such a system is done only in the case of daily products, sanitary wares, soaps, toothbrush, paste, and in such systems are used. Sorry, the production of such products are done using push systems. But for products that has to be stored in inventories and such, will always use a pull system. So according to the demand only, the production will start. So however, due to the inaccuracy of many forecasts, this can result in either too much or not enough product being produced to meet the demand. So, the forecast, if it is wrong in the case of push system, then they may produce either too much or not enough. There are two types. Okay, if the forecast, always it is a prediction, right? So the forecast will be inaccurate. Basically, it will be inaccurate, and either we will produce too much of the product, or we will not produce enough product for keeping the demand alive. So that is the problem of push system. But in a pull system, only acts when there is demand and relies on flexibility, communication, and efficient process to be successfully achieved. So the pull system, according to demand, only the production is done, and the products are produced, and that products will satisfy the demand. So it is always based on precise values, not a prediction, but precise values. So that is coming under pull system. And the last one is perfection. So what is perfection? The pursuit of perfection via continued process improvements is also known as Kaizen. So what is Kaizen? I will explain in the next topic. Uh, Lean manufacturing requires ongoing assessment and improvement of process and procedures to continually eliminate waste in an effort to find the perfect system for value stream. So you already know what is value stream and how it is mapped. So in under perfection category, it is said that each and every process must be perfect. So what it means is nothing but we are eliminating the waste procedures or the wastage of material or the wastage of time. So each wastages are reduced and optimized system of production or optimized system of work is being set for the uh, perfect lean manufacturing system. So that is coming under perfection. Okay, next. We will next look at some of the lean tools that are used to ensure that lean manufacturing is done. Okay, that is the next topic. So you can see there is about 11 types of tools. What is 5S, then continuous flow, level scheduling, Jidoka automation, just-in-time JIT. Just-in-time also comes under lean tools with sufficient changes. Then comes Kaizen, continuous improvement. Pokayok means mistake proofing. Value stream mapping, which we have already discussed. Then key performance indicator, visual management, and last one Kanban, pull system. Okay, pull system also we have learned. So 5S I will take in the next topic. We will start with continuous flow. So 5S is basically nothing but 5 S based rules that is set for as lean manufacturing tools. So it is basically sort, set to order, shine, standardize, and sustain. So when explaining 5S, I will tell you about that. We will look at continuous flow. So what is continuous flow? You can see it here. Work in process smoothly flows through production cycle with minimal or no buffers between steps of the manufacturing process. So it is basically what we have explained at create flow. Okay, so what we are doing, we are ensuring a smooth flow of the production cycle with by eliminating the waste incurred during that production cycle. So that is how we are ensuring continuous flow. So you can see here from process A to process B to process C. So it has to go in a smooth flow. There must not be any lag in between, as you can see here. So if it is not connected like this, you can see there is a lag here, right? If any defect is detected, countermeasures are taken immediately to rectify the error and ensure the smooth flow. So obviously there will be problems occurring, right? Maybe an equipment failure or any accidents that occur. So these are all coming under disturbed time or interrupted time. So these are unavoidable. So we have to design a system where if such a thing occurs, even smooth flow must happen. So for that purposes, they are designing a lean manufacturing system, and one of the tools that is used to ensure that is continuous flow. We have to set, so if the so in continuous flow, we are always determined. Suppose if the equipment fails, this is because maybe we haven't done the periodic maintenance or the maintenance that is required from the proposed by the company is not being done by the industry personnels. So if such a thing happens, obviously there will be a failure of the machine. So to ensure such a breakdown does not happen, we are doing or we will be doing periodic maintenance. So if we are doing periodic maintenance, the result of breaking down of the equipment will be avoided. So such a way to analyze or do a periodic maintenance also ensures continuous flow. So that is the function of continuous flow. So how does continuous flow help? So it helps in establishing the flow. So reduces batching, establishes process flow, minimizes waiting between steps. So between interdepartmental works or between each and every step or procedures of the manufacturing process. So it minimizes the waiting, then improves quality and reduces lead time. So these are all coming under, this is how it helps in establishing the flow. It also helps in eliminating waste of inventory. So the inventory waste is eliminated. Then waiting, the waste of waiting, that is time basically, that is eliminated. Then the waste of transportation. So transportation in the sense, okay, if in the case of a JIT technique, we are only creating product after the demand is occurring. Okay, once the demand or the order is occurring, we are preferring JIT technique. So in that condition, uh, the transportation that is occurring at that time or the supposed vehicle that is used for transportation for transporting the product to the consumer will be at a standby. So there is a waiting time occurring there. So that is what is known as the waste of transportation. So that waiting time occurring for a particular vehicle or a particular transportation mode will always be taken as a waste. So under continuous flow, it will not be happening. So it will be eliminated. So always the product will be available and the transportation waiting time will be eliminated. Then it also helps in increasing the profit in the sense, uh, helps in increasing the production with minimal waste, which in turn increases the profit. So we are reducing the waste. That is the lean manufacturing technique objective. So we are reducing the waste, thereby increasing the profit. So this is how continuous flow, one of the tools coming under um lean manufacturing, helps in increasing the profit. Next, next tool is level scheduling, Hejenga. So in Hejenga, it means sequencing or smoothing of production. So we are sequencing or smoothing of production. So in create flow, we are already creating a uninterrupted time for the continuous flow of work. But under level scheduling, what we are doing to ensure continuous flow is being done, we are preparing a sequence. So how the operation has to be done. So maybe first the cleaning of the material. Second, removing the impurities. Third, it may be after the impurities are removed, then it is broken down into small pieces. Then it is assembled, it will be melted or malted. So these are all the sequences or the steps for the processes that has to be done. So under these processes, which all equipments has to be used, how much time is required to complete this process, how to reduce the wastage of time during that particular process. These are all coming under sequencing. So we are sequencing the process and then thereby smoothing the production. So we are sequencing each every operations, how and first which operation has always to be done. So there is always an order to how you are doing the task. So multiplying the task and distributing them better, and by standardizing them by carefully studied smoothing, better use can be made of working time available for creating value. Also, when we are doing the process, we are not using a single labor itself. Okay, a single labor does not do all these sequences or these production production processes, but instead we are multiplying the task. So we are giving and dividing them to each and every one. So each person will be doing one job, and that job should be at its perfection. So that is coming under level scheduling. So we are scheduling each work, and each work is sequenced and give distributed to the sufficient personnel, and that personnel will ensure perfect procedures to be done under that production cycle. This ensures better quality of the product. So that is coming under level scheduling. So you can see how the level scheduling is there. In unleveled production, you can see one person here is packing, but part B line is standing still. So these guys are waiting for this to arrive, from A to arrive to following process, and from here part B and part C are waiting. But in a leveled production or in a level scheduling, part A is completed the work and given to the following process, and from there it is then transferred to the part B line, and finally it is gone to the part C line. So basically the storage area from level production to storage, that is what is shown here. And under level production, always a constant supply to the inventory is being done, but here there is interrupted time. So basically at B and C there is always a waiting time, and this is one of the waste that occurs during lean manufacturing. And how does Hejanga help? So it helps in monitoring and load balancing. So first we are monitoring how the if the sequence is being done in the proper order and how it can be done efficiently. So we are monitoring that, and then we are balancing the load. So each and every personnel is given a load of work to be done, and they have to do it at a perfection, right? So these are balanced. So the load is balanced across all the personnels and the production cycle itself, and this is done by Hejanga process. Next, it helps in better utilization of resources. So what are the resources that comes under? Factories, shop floor, machinery. These are all the resources that has to be used. So there will be a workspace, there will be certain machineries. So these all have to be taken into consideration so as to understand the time that it takes or sufficient operation that has to be done. So these all comes under the level scheduling process, and this is how the resources are better used for reducing the waste. Then last one, it helps in standardizing the work. So the works are standardized in the sense always the quality is maintained up to the standard. So maybe according to the consumer or according to various laws that are created to ensure the quality, that is ISO certification and all is given. That is given according to the standard and quality. So if you are standardizing the work, then sufficient quality of the product will be obtained from the production cycle. So that is how Ejenga helps. Next is Jidoka. In Jidoka, it is an automation system. So nowadays, labors are being replaced with automated systems more recently by means of robots and robotic arms, etc. So in automation technique, the problem is that human errors are eliminated. So many human errors may occur during a production cycle, and when you are using laborers, that is one of the problems that occurs. So if you are doing a periodic maintenance on sufficient automation equipments, then that equipments will provide the level of accuracy that does not apply with a human. So a human always may, due to maybe psychological problems or health problems, labor always encounter some defects or some errors during the work. So it is unavoidable. It may happen. But in the case of a maintained automation equipment, always the level of accuracy and quality will be kept at the constant instead of a human type. So you can see a depiction here itself. So here the products are coming, and when it finds out a defect, the machine is shut down immediately to remove the defect and then continue the production cycle. So the quality is not up to the mark because this machine may test the quality here. So if the quality is not up to the mark, it is then removed and it is termed as a defect, and this is only possible during a automation technique. So quality is the source of automation. To ensure quality, automation technique is done. So it is based on this principle, three don'ts, and don't accept defects. That is the first one. Next is don't make defects, and last one is don't pass defects. So don't accept, make, or pass defects. That is coming under Jidoka technique. That it helps in eliminating waste of defect. So that is another defect. So any defective product that occurs is always considered a waste. Consumer does not pay for that defective product. So it is always termed as a waste under lean manufacturing. So it eliminates the waste of defect. Next, it ensures client or customer satisfaction. So if a quality product is obtained, the customer is always satisfied. So he will always prefer that same company and that same product, which further increases the profit that is incurred by the company. Next, it reduces labor costs. So always an automation technique is used. Majority of the system will be an automation equipments, and due to that, labors are less. So we are only spending money for the maintenance of these robotic equipments. So for that, the labor cost will always be less. Next, it reduces lead time or turnaround time. So it reduces lead time. Lead time in the sense of inventory will be always less. It reduces the lead time. This is because an automation technique will take faster working procedure. So it may produce products. The products produced will be higher when compared to human production process. So under automation technique, the robotic arms or the robotic equipments will produce the products at a faster rate. Okay, so that helps in reducing lead time. Okay, I'll wind up today's session.